Hi, I'm Gavin Bierman. I'm a researcher in the Programming Principles and Tools group here at Microsoft Research in Cambridge.
And what does that mean?
Well, it's actually the world's best job. We're full-time researchers, and essentially we're a bit like academics. So we're thinking up ideas, exploring them, writing papers, journal articles, and so on. Um, but we don't have to do any teaching, so it's really a very nice job.
Great. And what particular technologies are you researching or working on at the moment?
Well, my particular area of interest is programming languages and also database query languages. And one of the main projects that I'm working on at the moment is a new programming language called CMega. So the reason why we're coming up with yet another programming language is common software that's been written at the moment are sort of data-intensive distributed applications. Um, so typically these are architected with a sort of three-level architecture. So you have your core application, your business logic, and that's written in a language like C#. And then you have upper and lower tiers, the upper tier being some glue to essentially convert your application data to XML or HTML, so some semi-structured data. And then you have a lower tier, which is connecting your application to a database. And indeed, if you listen to users of C#, the majority of them say that what their applications are doing is communicating with databases. And also, these applications are distributed, so they're running across networks and so on. And what we're trying to do is make writing that software easier. When you actually try and write this code, you realize that a lot of these features are provided to you via APIs, via libraries. And there are serious weaknesses with this, and those are the sorts of things we're trying to address.
Do you have an example of one of these weaknesses and what you've done to work around that?
Sure, so let's consider the data aspect. So communicating with databases. So lots of people use the libraries to communicate with, say, SQL Server from C#. And what you find there is that there's a serious problem. There's a big mismatch between the data model of C#, which is objects, and the data model of SQL, which is the table and nullable types, and also this query language, SQL. And there's actually just a big difference between those two worlds. And they don't particularly sit well together, and you tend to write code which is essentially just plumbing data back and forth. It's very fragile. You get back something of essentially an object class, and then you cast it down to whatever type you think it might be. And the trouble is that the errors you get are at runtime, they're not at compile time. And also the other problem is that to query the database, the APIs provide you with methods to send queries to SQL Server, but you send them as strings. So you can't check the query at compile time at all. Anything between two quotes will compile correctly and get sent to SQL Server. And then at runtime, I guess most people are familiar with this bug, or this bug in your software, you get an error message back from SQL Server saying that wasn't a valid SQL query. And that's a shame because SQL has a well-defined grammar, and we ought to be able to do something at compile time to make that easier.
Okay, so do you have an example of how you've worked around this with CMega?
Yeah, so in CMega we did a number of things. One thing we did was look at the data model of SQL and also of XML and try to abstract out what was there. I mean, clearly the core problem is how you're going to bolt all of these data models together. If you want them to coexist in a nice way in a language, how are you going to get them together? And what we did was we looked at, say, the relational model and had just tried to abstract out the essential features of this data model. So essentially a table is just a stream of rows, of records. So stream is something new. A record is a bit like a struct, but it doesn't have a name. So what we've done is abstracted from a table to come up with two new data types, a stream type and also an anonymous struct. And we've done the same with the XML data model to introduce another few new data types into our language. Now, once you've done that, you have a nice integration of the data models, and then you can approach the querying aspect. So then you can actually build in the query languages directly into your programming language. So let me show you some examples.
Great. Examples are always good.
Yep. So here's a piece of CMega code, and what it is essentially just sending a query to the Northwind database. But really the point here is, so it's doing a select from where it's doing some group bys and some ordering. The real point here is that the select query, unlike in the equivalent C# code, this is first class, right? In the sense that this is in the language itself. So if for
So
example,
I don't see any quotes around this, like
exactly,
passing a string.
exactly, it's not a string. This is actually the select syntax is in CMega itself.
And you can see color highlighting for the keywords in here as well.
That's right. So let me make a mistake. Let me change that inner join to inner with a single N. You see that instantly Visual Studio has come back and said, but that isn't a valid query. I don't understand what you've done. Even better, it's not just syntax, it's also types. If you look here, this is doing a join on some product IDs. If I just hover the cursor over, you see that Visual Studio is telling you that product ID is a SQL integer, 32-bit integer. So this is really first class in the language, both the types and the query itself. So that sort of whole class of runtime errors that we're familiar with using libraries with SQL Server go away in CMega. The query itself is in the language. So let me show you another example, but this time with XML. So again, having extended the data model of C# with sufficient new constructs to represent XML, you can actually write XML directly in your language. So you see here we've got the familiar angle braces, and you see it's got color highlighted because this is actually part of the language. You can write real XML fragments in CMega code, and it's checked by the compiler. This is in fact one of the W3C use cases. It's asking to go over a bibliography of book data and just return the title and authors. So here is the example code in XQuery as given to us by the W3C. And here's how you write it in CMega. And really the point here is that it's almost the same. You see here we're doing an iteration. We're returning a value. In CMega we write yield return. We're returning a little piece of XML here, so something between tags. We have those tags first class in CMega. And the only difference is that in XQuery they have the XPath fragment to go over data, and what we've done in CMega is just generalize the dot operator. So we're used to in C# using dot to extract fields from objects, and we've just extended it so it operates over all the new data types. And the cool thing is that the way we've designed that is that roughly speaking, everywhere where you wrote a / in XPath, you just write dot in CMega. So all your C# code runs as it would do, but if you want to start writing code that looks like XQuery, you can write that as well. But of course, the beauty here is that this isn't, even this language here is XQuery. This part is just a fragment of CMega. So you've got both the power of a significant fragment of XQuery plus the whole of C# as well. So let me just show you another example, just because it's something more interesting to look at. It turns out that people have defined an XML format for scalable vector graphics. So in other words, you can write XML's documents which represent graphical objects. So here is a bit of CMega code which is printing out graphics but using this XML format. So here is a method called face, and what it's doing is just returning a huge blob of XML which is going to print something pretty on the screen. So let me just run this code so you can see what it does. So if we click on the face button, so this is just invoking that method that I showed you. So it's returning a piece of XML and then using the standard routines which take this XML representation of scalable vector graphics and rendering it on the screen. So here is a face, and here are some other examples of graphics that have been generated in XML using this standard. So again, really the beauty here is that you can write this XML first class in the language itself.
Can I embed function calls directly into that code so that the XML that's being generated can also be calling out to functions to return modified versions of the data?
Absolutely. So here's an example, the lines one. This was the part of the demo that drew the grid. Here what it's returning is a piece of XML, but in fact the inner core of that piece of XML is a method call. So you just escape out using the curly braces. So this is a method in fact defined just below to generate more of the XML data. So yes, you can.
Okay, that's very neat.
Okay, so the other thing I should mention is that this compiler is available. If you go to research.microsoft.com, click the download icon, you'll see various things that are on offer, but one of them is COmega, so feel free to download it and play with it and let us know what you think.
Okay, I guess one question that the viewers may have is, all this looks great. Direct integration of SQL commands into the language, direct integration of XML into the language as well. Are we going to be seeing this in the next version of C#?
Yeah, we get asked this all the time. We are separate. We're Microsoft Research. We're not part of the product team, so we don't work for the C# product team or the Visual Studio team. So what we're doing is not guaranteed to make it anywhere. That said, though, the C# team keep a close eye on what we're up to, so we're always hopeful.
I guess the lead-on question to that is, if I can download all these bits directly from research.microsoft.com and I get COmega and I can build a binary application built on that, it's going to be MSIL. Can I ship that application without any problems?
Yep. Yes, you can. Yeah.
Fantastic.
Free download.